Let's talk about set notation. First, what is a set? A set is a collection of distinct objects, which are called its elements. So the distinct objects, meaning an object is either in the set or not in the set. If it goes into the set for multiple different reasons, it still just counts once. So you wouldn't list the same thing multiple times within a set. So an example, two different sets whose elements are 0 and 1, one of them being the set of all digits of the number 1 million. So it has 1, it has 0. It doesn't matter that it has 0 more times. The set of its digits is still just 0 and 1. The set of all x such that x squared equals x, 0 squared equals 0, 1 squared equals 1. So those are both in the set, and there's nothing else in that set. So you can have the same set that comes from many different sources that could be used to define that set. All right, set notation. The main one you'll see kind of if you're paying attention. So this is roster method. You have curly braces enclosing the set elements. The set elements are separated by commas. The order of the elements doesn't matter, but again, elements will not be repeated in your listing. And this is generally used for what we call finite sets. There's a limited number of elements in the set. You can list them and you run out eventually and you're done listing the elements. You will not include variables inside braces. So you wouldn't put x equals 5, anything like that. You just put the numbers, the actual values. So in your homework, again, you won't be putting in the curly braces. You'll see them if you're paying attention outside of your answer box. So when you have an answer box that's just inside of curly braces, as shown here, that's where you would list your answers separated by commas in any order with no repetition, no variables, no equal sign. So some examples of this. So we have a problem here finding the set of all digits of the number 3,273,333. And there's an answer box enclosed in curly braces. So we're looking for which of these potential answers typed into that box would be accepted as correct. So the first one we have 3273333. That would not be accepted. The 3 does not need to be listed more than once. So once 3 has been listed into the set, then it doesn't get listed again. So those extra 3s shouldn't be there. 327 separated by commas, that includes all the digits. That one's good. And then 237, listing them in a different order is fine. So the order doesn't matter. Don't list anything more than once. Another example, so we have solving the equation x plus 1 equals 3, and again, an answer box enclosed in curly braces. We're looking for any of these answer entries that would be accepted as correct. So what do you add 1 to get 3? That would be 2, but x equals 2 would not be accepted. We don't want the x equals going into that set roster notation. The number 2, that's good. That's exactly what you would put in to that set notation. You would not type the curly braces because the curly braces are already there. So you don't want to have curly braces inside of other curly braces. All right, so then another way to do set notation is called set builder notation. So this is where instead of listing the individual set elements inside the braces, we have a variable defined, and then we have a rule that says what's going to make something be part of the set, what values of the variable would be in the set. So we have the curly braces, which indicate a set. We have the variable. So we're saying the set of all, whatever, usually x. So the set of all x, and then there's a vertical bar. The vertical bar means such that. So we have the set of all x such that, and then there's a rule. The rules will often be an inequality or multiple inequalities. So x less than 5, x not equal to 2, etc. The variable we have before the vertical bar, but you'll still include it in the rules. So in the inequalities, if it's a rule written out in words, you'll still have the variable in it. So it's the set of all x such that x meets these qualifications. So in the homework, you'll generally, again, have part of that notation given to you. So all you would be typing into the answer box, you already have the curly braces, you have the X, you have the vertical bar. So you're just entering typically inequalities into that answer box. So your X less than 3, X greater than 5, etc. So this is typically used for the solution of an inequality. So here we would say that solution set contains infinitely many values. So if I'm looking at values greater than 5, 6, 7, 8, 9, 10, I could keep counting forever. And also anything in between 5 and 6. And I could list forever, just listing things that are between 5 and 6, etc. So this notation allows us to describe those sets that have infinitely many values within them. Some examples of set builder notation. So one, we have the set of all even digits that could be given in set roster notation. It's 0, 2, 4, 6, 8. In set builder notation, we have the curly braces, we have the X, we have the vertical bar, and then the statement X is an even digit. So that would be read the set of all X such that X is an even digit. The set roster notation then lists out what those digits actually are. But many sets that we would give in set roster in set builder notation couldn't be given in set roster notation. So for example, the set of positive integers or whole numbers we could list as 1, 2, 3, 4, and then we could use ellipses to indicate that that pattern continues. But if we have a set that's a group of real numbers, then typically that can't be done. So if we say the set of all positive real numbers, we can't list those out. First of all, there's no starting number. There's no first positive real number. So if you say, well, the first positive number is 1, well, 0.1 is also positive and it's a real number. And then I can go smaller than that. I can go 0.000. I can keep adding more zeros. No matter what number you give me, I can say I can give you a number closer to 0. A number that would come before that in the list of real numbers, of positive real numbers. And you can't establish a pattern. So no matter what you list, I can always come up with other numbers that would be in between there that are being left out of the pattern. So we can't list kind of that type of set of real numbers in set roster notation. But we can easily list them in set builder notation. So one thing is just excluding a single number. So the set of all real numbers except 2 can be written as X such that X is not equal to 2. So rather than listing out what's in this set, we just know what's not in the set. And then the set of all real numbers less than 2 or greater than 4. So we have the set of all X such that X is less than 2, comma, X is greater than 4. Or as I was talking about before, the set of all positive real numbers, the set of all X such that X is greater than 0. So some more practice and examples of this. So you have the answer box with the set builder notation. What would you enter for each of these sets? So the set of all real numbers less than or equal to -3, what we would type in is X less than or equal to -3. So again, you do include the X in the inequality. And then we have the set of all real numbers greater than 4, except for 7. So we would have X greater than 4, and then we also have to say X doesn't equal 7. So we would have those two inequalities separated by a comma. Those really could be given in either order, but typically we kind of think left to right on the number line. So the 4 kind of being greater than 4 comes first, and as we're going greater than 4, we get to 7 and say, wait a minute, this one has to be left out. So that's set notation.